Okay, let's talk about the baluster layout section. Um, so after you've gone through the newel placement section, you get into this baluster layout section. We've got a slide here, um, just the term baluster. You can have a student read. Now, there could be a lot of apps out there you could use for this. I use the Construction Master 5 app. They need something that can add and subtract fractions and do it properly. And so we've just had them download this app before we start this process. So if we go to, let me see if I can open this up. Alright, so this is the start of layout. We do it in a couple different ways, but this is the first one. So the first one is, this is how I always did it when I installed. The place you most likely will end up out of code on a stairway is right here. Okay, this post is going to taper in, and where that post tapers in, you're not going to take that into account, and you'll end up out of code. So I always started off of the face of my newel post a set dimension, 3.5 inches. That allowed for that taper, and that ensured that I would never be out of code on my starting and ending on a newel post. So we're going to do it that way first, and then we'll do a few others. So the instructions are down here. So it says, and we just follow the instructions and go through this with the students, floor level baluster layout from first baluster steps with a calculator. Okay, so these are the steps to do it if you're doing a fixed dimension off your first baluster. So you lay out your newel locations once you're in the house. If you've got long runs, make sure you have identical spaces in between your newel post, otherwise it's not going to look right. Mark out your first baluster off each newel. That's this 3.5 inches, 3.5 inches. Measure the space between those two balusters. We've already done that. It's 67 and 11/16. I'll grab my calculator here so I can do this while we actually. So now I got my Construction Master calculator open, and let's see. Measure the space. Divide opening by maximum baluster spacing, then round up to get the total number of spaces. So if this is, let's call this a 5/8 baluster right here, pin top baluster. So we know that we can't have more than 4 inches in between, so 4 and 5/8 would be our max on center space that we could go. So I'm going to take 67 inch 11/16 divided by my max number of space, which is going to be 4 inch and 5/8. Okay, so that's going to be 14.6. Now what does it say? It says divide by the opening by the maximum baluster spacing, then round up to get the total number of spaces. So that means we have 15 spaces. Okay. Now it says divide the opening by the number of spaces to get the baluster spacings on center. So we rounded up to 15. I'm going to go back to 67 inches, 67 inch 11/16. Okay, divided by 15. So that's 4.5 inches. So I know that my baluster spacing on center for these is going to be 4.5 inches. Let's see. Divide opening by the number of spaces. Lay out the space with the dimensions you got. Adjust spacing as needed. Quarter inch adjustment is acceptable. What that means is that this is rounding. So the calculator is giving me 4.5 inches. It's not really a true 4.5 inches. So chances are I'm going to start at the beginning, and by the time I get to the end, I'm not going to be 67 11/16. So let's try that. There was 15 spaces, so 15 times 4.5 gives me 67.5. So you can see that 15 spaces at 4.5 is not 67 and 11/16. It's 67 and a half. And so you've got some adjustment there. Now, it's not very much. Adjustment was at 3/16, I think. So if your last baluster spacing is 3/16 off, well, that's acceptable. That's a small enough variance that you're not going to have an issue. So I just wanted to make sure that they're aware of that as they go into this. Okay. So that's the floor level. Then we look at the rake. Okay. So we have, let's see here, up here, diagram 1, cut stringer layout steps. So this is a cut stringer. We call it sawtooth or open stringer, whatever you may call it in your part of the country. And it says determine the run of the stair. So we've already got that laid out for us. The run of the stair is 10 inches. Divide the run by the number of spaces per run. Well, this is a 2-2-2 pattern, which means there's 2 spaces per run. So that means that these are 5 inches on center. Now 5 inches on center is kind of wide, but as you can see up here, remember we're allowed 4 3/8 on the open side of a stair run spacing. So we are still in code even with a 5-inch on center spacing. So once you divide that run by 2 spaces, then you have to decide where those balusters are going to land on those steps. Let's say this is, I don't know, maybe that might be 1.25 inches back, 1.5 inches back. So this would be 5 inches more than that, so that would be 6.5 inches back from the nosing, whether you're going to measure from the riser this way or from the nosing back, whatever it may be. These are going to be identical on every single one of your steps, okay? But you've got to think about this newel post and making sure you're in code here, and this newel post and making sure you're in code here. So that's your spacing. You just got to work on how it ties in at the top and the bottom of the stair. Okay, so that's slide number 1. Maybe I'll just keep going here. Okay. This slide is to allow students to remember that where they set their post is going to greatly affect the layout of their stair. So we would often do 36-inch rail height on the rake and 38-inch rail height on the floor level. And so what we would do is we would set our level on here, and we would come back until vertically it measured 2 inches, which you can see is 2 5/16 back from this nosing. But once you hit that point, if that's the face of your newel, that means that this rail at 36 is going to meet this rail at 38. So you're compensating for that height difference. Not everyone does it that way, but you need to know which way you're going to do it and where you're going to set your newel post. Here's some examples of that. You can see that this is a curb wall stair here, and you can see that it looks like we're a long ways back from this joint transition, but if you look at the nosing and the riser, we're actually pretty close to where that nosing and riser transition is. And this is what I mean by this rail is set at 38 inches, this rail is set at 36 inches. So they meet at the same height on that newel post. Okay. In this scenario, we already talked about this, but this one had to gooseneck up in order to reach that height. Okay. So that's one other way to accomplish it, or you can have transition posts, and we already talked about that as well too. So when you're setting your posts, you've got to take into account all of these different options and the layout of your balusters. Okay, so depending on how far back you set this newel post, you're going to have to adjust this baluster or this baluster spacing. Okay, so this is the same thing. The floor level, I'm just having the students, I'm taking away one dimension, so I've changed these dimensions a little bit. You can see this is 78 3/8 from face of newel to face of newel, and what was our last one? 74 11/16. So I'm changing it up on them, forcing them to do the math again. So and I've taken away the dimension from center of this to center of this. So they're going to have to do the math to find that out, and then divide that out and figure out how many balusters at what space. The difference we have here as well is we're showing a 2-3-2 spindle pattern or baluster pattern on this stairway. That's going to be a different set of math, and we've done that up here. So because this is a 2-3-2, it means we're going to use 2 runs to get our spacing. So you got to add those 2 runs together. So we got a 10-inch run and a 10-inch run. We're going to add those together. That gives us 20 inches. Now we're going to divide that by the number of spaces for those 2 treads combined. So on the last one we did divide by 2. This one we're going to divide by 5 because there's 5 spaces there. So if I do that real quick on my calculator, what do I got here? 20 divided by 5 spaces gives me 4 inches. So my spacing between these balusters center to center will be 4 inches, and that will give me an even layout on this. And then decide where the baluster should land. I always used to go, what I do, 159 and then 37, and then I go 159 and 37, 159, 37, and I knew if I pulled off my nosing 1 inch, 5 inch, 9 inch, that these would be 4 inches apart, and if I went 3 inch and 7 inch, that these would also be 4 inches apart, and I would stagger that layout and go all the way up the stairs that way. So that's how you do a 2-3-2 pattern on a cut stringer, and the baluster layout on this one did not change. Okay. Similar scenario here, we just have, again, I've taken away some information to make them work a little harder. Change this dimension, they're going to have to do the math again. Now when we come down to here, this is a 3-3-3 pattern. So we would take that 10 inches, 10 inch divided by 3 spaces, and that's 3.333, or if I convert that, 3 5/16 of an inch is our center to center space here. Okay. Again, just showing them some alternatives on what they might do for the layout on a stair. Baluster Pro Video. This is the next app we want to use. Ken Carter from Restair taught us about this. I had never seen this app, but if I were to be teaching someone new to do stairs today, I'd probably use this app because it's incredibly simple. Okay. So you can see the video playing there. So what does that do? Well, you can watch the video for that one, I guess. Do I need to go into his video? Will explain how to do this. Let's see. So I'm explaining here how you might do it with a calculator and how you would do it with the Baluster Pro app. So if you just follow those directions and play around with your Baluster Pro app, you would want to get familiar with this before you're in front of the students so you can help them out and help understand it. But it's pretty simple, and it's a great little tool. So these next ones, again, same process. We're just trying to be repetitive. We want them to know how to use this. You can see here the problem. We've got a 2-3-2 layout pattern. You can see how tight this one ends up to this newel post, so that doesn't look very good. So that's one of the things to just make the students aware of as they're doing the layout. They need to watch for that. Okay, so this is, pin tops. These are mission style or square balusters. This is again a 2-2-2 pattern, just showing them a few different options there when they get to do layout. This is just trying to get repetitive with them so that they can use this 3, 4, 5, 6 times during the class. So when they leave the class, hopefully they will remember this stuff. This is again, I think Ken Carter gave us this option. When you're doing a patterned layout, you can talk to your client and say, do you care about picture or pattern? Okay. Let me explain the difference between those two. This is a pattern layout. So this pattern flows up through all the way across. But when you do that, you can see you have a scroll right here against your newel post, which doesn't look very good. So you got to decide, what do we do to make this look right? And does your client want this pattern to flow all the way up, or can we mess with this pattern a little bit to make this picture look better? I'll show you what we mean. You can see here we've taken away one of the balusters on this end and moved it over, which looks better than it did probably, but still not good because you have a different baluster on each side here. And if we relay it out this way, now you have what we would call a picture. Okay, so this picture is symmetrical and it looks nice. And when you pick up and start your spacing on the other side, it may not be, the pattern might not flow all the way through and continue, but the picture you get off of each section looks correct. The only way to make this happen in a baluster layout with wrought iron balusters is to have an odd number of balusters. See this little tick I put right here in the drawing? That tells you that's the center. Okay, so that allows you to put one baluster in the center and know that you're going to end up the same on this side as you are on this side. Okay, so when you divide these out and you let's go back. I'll show you how that works. So here we have 66 and 15/16. So I'm going to go 66 inch 15/16 in my calculator, divide by max spacing, which would be 4.5. That gives me 15 spaces, which would be 16 balusters. But we don't want 16 balusters because this is what we end up. So what you'll do is you'll round up one more. So instead of dividing by 15, if I divide by 15, I'm going to end up with what you see here. Or I can divide by one more and end up with this. So that's a good thing to teach the students, is to make sure they know if you want an even uniform pattern, you're going to need to have an odd number of balusters in each one of your spaces so that you can be even on both sides. Okay. What else do we got here? A couple more examples. Again, what we're doing same thing on the rake, 2-3-2 pattern. On the floor level, we're just showing a few different options that come about. So determine the pitch of a rake with a Construction Master calculator. Type in 10 inch and hit the run button. So I'm going to type 10 inch. I'm going to hit this up here that says run. Okay. Next thing I do is type in the rise, which is 7 3/4, and hit the rise button. So I hit 7 inch 3/4 and hit the rise button. Okay. And now hit pitch, which is the first button on that top row. That tells me my pitch is 37.78 of an inch. Okay, I'm going to write that down. 37.78. Okay. Now, determine the diagonal dimension of the rake with the rise and run. If we got that same information, we don't even need the pitch, but we could use the pitch. So we're going to type in 10 inch run. Okay. Now I need the rise, so I'm going to type in 7 inch 3/4 rise. Now instead of hitting the pitch button, I'm going to hit the diagonal button. That diagonal button tells me from point to point, from nose to nose on my stair, I'm 12 5/8. Okay. You can do that for the whole length of the stair. You can do that for one run, but these are things you'll need to know in order to calculate layout on a rake. Okay, so the next feature we're looking at is to determine the diagonal dimension of a rake with a pitch on the Construction Master calculator. So now we know the pitch is 37.7. Okay, if we were doing a wrought iron, a 1/2 inch metal baluster, okay, we know our max space would be 4.5 inches, but that's 4.5 inches measured vertically, not horizontally. We want to know what is this dimension not horizontally, but on a pitch. So Construction Master will do that. I'm just going to punch in 4 inch 1/2 into my Construction Master calculator and hit the run button. Okay. Type in pitch, which is 37.7. So I'm going to 37.7. I'm going to hit pitch. Okay. So now it knows my run, it knows my pitch, and I'm going to ask it that diagonal button. I'm going to hit diagonal. So that's 5 11/16. So I know that to get 4.5 inch space this way, I need to measure 5 11/16 this way. Does that make sense? Okay. So these are the three features on the Construction Master calculator we want them to be able to do, so they can determine the length of the layout on a pitch. Okay. So if we were to take we already know that it's 5 11/16 is our max space, and you can see my center to center baluster here is 96 and 15/16. So if I were to go 96 inch 15/16 divided by 5 inch and 11/16, it tells me I got 17 spaces, and we round up to 18. So I would take that 96 inch 15/16 divided by rounded up to 18. So 5 3/8. So I would start here and I would mark 5 3/8, 5 3/8, 5 3/8, 5 3/8, and go all the way up. Okay, that's how you do that with a calculator. Now the next is the Baluster Pro app. I can open that up real quick and see if we can do that together. Pro. So we're looking at a stair run. Okay, and it is, you can see we are 107.5 from skinny point of this newel to skinny point of this newel. 107.5. So length is going to be 107.5. Okay. Baluster width, we're going to do ½ inch. This is 5/8. I did ½ inch in my other example, but we'll leave it at ½ inch. We know our pitch is 37.7. This goes every half a degree, so we got to go 37.5, and we're going to run up until we have less than 4 inches in between our balusters. So 3 13/16. So that's 19 balusters, or 18 spaces, which is exactly what we did on the last one. And our space on center is 5 7/16. It calculated out to 5 3/8 when we did it before, but very similar, you can see. And then we can hit that mark centers button, and that allows us to just pull our tape measure from the bottom of the stair all the way up, and you can see it gives us 102 7/16 at the end, so we're off by 1/16 of an inch. So this is how you do it in Baluster Pro, which is quicker, easier. That's what I would recommend doing. Okay, this again is another practice for them to practice. All right. So at this point in time, their brains will be fried. They're trying to figure all this stuff out that we've been going through. So we put a break in here, try and shift gears, just let them go to something else. We want to come back to it, but, and I'll show you what happens here when we come back to it. Okay. When we come back, what we want them to do is take this sheet here and do the baluster layout, use what they've learned, and write how many balusters and what is their spacing on center for each one of these parameters. That'll give them a chance to work it all out, and then as a group you can see how they did, you know, what they might have done wrong, what they got different from their partner, whatever it might be. You'll notice here I say, what's wrong with this layout? How would you fix it? What's happening here is this is 93 3/8. This is 93 3/8 from the center of this newel post to the center of this newel post, but this is 93 3/8 from the wall. That means that your open space here, let's call this a 3-inch newel post, from face of newel to face of newel is going to be 3 inches less, because you've got 1.5 inches here and 1.5 inches here. So that makes your open space here 90 3/8. In this section, you're only subtracting half of this newel and nothing on this side. So this one's going to be, what does that make that, 92 7/8? So they're not going to be the same in both of those locations. So you have to be able to walk them through that so they can see why that is, so they don't make the mistake when they're in the field. Again, this one goes through, this one does a rake section, 2 rake sections, a little floor level piece here and a floor level piece here, so get their brains going. This is another one. You got a little rake section down here, a little rake section here, and then you got an upstairs floor level, another floor level. Okay, so that's kind of roughly how I would run through that section.